right, these are notes 11, and you'll have Math Excel number 11 for asynchronous learning time. This section is about quadratic functions again. We're still graphing. The difference is this could be your essential question if you're trying to make Cornell style notes or focus notes. How do I graph quadratic functions of the form y equals ax squared plus bx plus c? So we have a full standard form quadratic, and I'm going to show you guys how to graph it. And remember, you can always use Desmos.com, but that is more, I don't want to say cheating. It's like if you don't know how to graph by hand, then you can use Desmos, but you need to learn how to graph it by making a table, which I'll show you today. The warm-up should be done. If you haven't finished it, you can copy it right now and work it out on your own. This is a really good part to look at in the book. Again, oops, I forgot to say it. This is page 720 in your book, so make sure you are on the right page, page 720. But I'm going to skip it right now because it takes kind of a long time, and you can just read that on your own. The main thing is what's over here, this key concept. So this is page 721. And the key concept is telling you the x-coordinate of the vertex. So if you have an equation like this, the vertex is not at 0, 0 anymore. It tells you what the axis of symmetry is. And remember, that's the straight up and down vertical line that basically slices a parabola in half. It goes through the vertex. And then this is your x-coordinate of the vertex. So when we're graphing right now, I'm going to be talking about this a lot, how we have to do negative b over 2a. That's going to give us our x-coordinate. So remember, our standard form of our quadratic is ax squared plus bx plus c. If we're doing negative b over 2a, the b is the middle coefficient and the a is the leading coefficient of x squared. All right, so I'm going to go ahead and go over how to do problem number 1. Or it's the got it for problem number 1. So remember, we're going to need the a and the b. We're going to do the x-coordinate of the vertex is negative b over 2a. So we're going to do that a lot. And same thing with in your Math Excel. Make sure you're doing that. All right, so what is the graph of this? First of all, I can tell this graph's shape since it has a negative in front of the x squared. It's going to be reflected. It's going to point downwards like that. And the vertex will be at the top. It will be a max. That's some stuff I can just tell right away by looking at the equation. All right, and then to know the axis of symmetry, we're going to say AOS for axis of symmetry. That's where we're going to start doing our negative b over 2a. So I can also write A, B, C, if that helps you. It coordinates right here with this A, B, and C. As long as it's in standard form and in order, that's how you write it. So A equals negative 1, B equals 4, C equals negative 2. So in this, for this quadratic function, it would be negative, and then B is 4. Oh my gosh, I wrote B. Okay, so negative B is 4 over 2 times, that means times A is negative 1. And then I just have to simplify that. So multiply on the top, multiply on the bottom, that would be negative 4 over negative 2. And then simplify that, the negatives cancel out. A negative divided by a negative is positive. 4 divided by 2 is just 2. So my axis of symmetry is 2, x equals 2. I should write x equals at some point. Okay, so x equals 2. When I get my vertex, the vertex value is 2 for x. So what I can do when I do my xy table is I can, this 2 is going to go in the middle, and then I do 2 less and 2 more. So I count backwards, 2, 1, 0, 2, 3, 4. So this helps me figure out my table, my XY table, and then I can graph after I get these values. So I'm going to go a little bit quick when I'm plugging in numbers and solving, just because it can take a while. So I'm going to use my equation y equals negative x squared plus 4x minus 2. So I'm just rewriting the equation, and then I'm going to substitute those values in for x. X is in two places also, so notice that. And I do want to remind you guys that parabolas have symmetry. So if I set up my table correctly, I should see a pattern repeating. Okay, so I'm going to start by plugging in 0. I'm going to do 0 mentally. If I plug in 0, 0 squared is 0, it's 0. 4 times 0 is 0. So all that is 0 minus 2. So that would be negative 2. All right. And then I'm going to plug in 1. So I'll work this one out. So there's not a lot of room. I'll just work it out below. If x equals 1, it's negative 1 squared plus 4 times 1 minus 2. And you just have to work it out following order of operations. So make sure you're writing this down. Make sure you know how to do it. 1 squared is 1, but then it's negative 1. That negative is not part of the squaring part. It'll make whatever's inside negative. So negative 1 plus 4 times 1 is 4, minus 2. Go left to right. Negative 1 plus 4 is 3. 3 minus 2 is 1. All right. Then I'm going to plug in 2 into the equation. So negative 2 squared plus 4 times 2 minus 2. So I'm just using this equation to plug in 2 anywhere I see x. Then I just work it out. Remember that negative stays there. 2 squared is 4. 4 times 2 is 8. So I did exponents, then multiplication. And now I go left to right, adding and subtracting. So negative 4 plus 8 is 4, positive 4. Minus 2 is 2. So far I'm not seeing a pattern, but I should see a pattern very soon. The pencil is like reflective with the light. I hope you guys can see that. Okay, there. All right, so I'm going to plug in 3 now. So I'm going to do same equation, negative 3, sorry, negative, and then parentheses around the 3 squared plus 4 times 3 minus 2. So that would be negative 9 plus 12 minus 2. Negative 9 plus 12 is 3. 3 minus 2 is 1. There's that pattern. Okay, so I should have negative 2 when I plug in 4. I'm going to do it mentally. So I'm going to imagine right here I'm plugging in 4. So 4 squared is 16. That would be negative 16. 4 times 4 is 16. So negative 16 plus 16 cancels out 0. 0 minus 2 is negative 2. So that is correct. All right, so that's how you get the chart filled out. Remember, it all started with this negative b over 2a. That way I have my vertex. That's the vertex. And it's also the axis of symmetry. I'm noticing all my points are they're good to just be graphed. If I center the x and y axes in this little grid, so I don't have to worry about like sliding it anywhere or counting by 2s. Everything should fit really nicely looking at my values. All right, so my x's go from 0, 1, 2, 3, and 4. And then I just have to plot my y's. So I'll use a different color. Okay, so my first point is 0, negative 2. So where x is, also that's y. So where x is 0, y is negative 2. So negative 1, negative 2, put a point. And then I've got 1, 1. So x is 1, y is 1. Yeah. And then 2, 2. 1, 2, 1, 2. So 2, 2. Now we'll see our symmetry because this one should be the vertex. So 3, 1. 3, 1, I'm seeing it coming back down and it's reflected across this axis of symmetry. We usually draw like a dotted line to show the AOS. AOS, axis of symmetry. And then the last point, 4, 2. Oh, sorry, 4, negative 2. 4, negative 2. Again, we've got symmetry here. From this point, I can count 1, 2 to the axis of symmetry, and then 1, 2, and then there's that point. To complete the graph of the parabola, just connect with a curve, and then there we go. Okay, so that is how you graph. So it's very similar to what we did before in section 12-2 in notes 10, except we have to do this negative b over 2a, and that's where we start and make our table. Okay, so we'll go ahead and do another example. Oh, one other thing, I do actually want to look at this question. This B reasoning thing says, why was it useful to use the y-intercept as one point on the graph? I didn't really talk about it, but it says it on the other page. This C right here is the y-intercept. So it'll be crossing the y-axis at -2, which is right here. So whenever you plug in 0 for x, you get your y-intercept. And it's also really easy to plug in 0 for x. So that's a point we usually do want to pick. And I always put my points in order. So anyways, that last number is always going to be where the graph crosses the y-axis. So you can see it's at -2 here. And just to show that for the next problems, we may not graph both of them, but you can tell by looking at the equation, this one would be at 9. So that's the y-intercept. And then this one would be at 1. That's where it would cross the y-axis, just like how it did here. It's not the vertex, but it's where it crosses the y-axis. Some little part of the graph is going to cross through for this one at 9, for this one at 1. All right, so I don't want this notes video to get too long, so I'm actually just going to help you get both of these set up, and then I want you to try to finish graphing them. So I want to help you guys get your negative b over 2a, and then you're going to do your x, y table, and then graph it. So same thing here, you're going to do your negative b over 2a, and then your x, y, and then you're going to graph it. You have to have your 5 points to graph the parabola. We'll have to have well, on the one above, you can tell the vertex, 2 on the left, 2 on the right. And this gives us our vertex point. So if it helps you, I know it always helps me, write down underneath A, B, C. And then you'll know what numbers, always take the sign in front, what numbers to plug in. So if it's negative B over 2A, you just have to plug in the B and the A. I always set it up like that. So my B value is 8 and A is -2. And then you just work it out. That would be -8 over -4 and divide it to get 2. -8 over -4 equals 2. So just like that last one, I want to use 2, count 2 less, 1, 0, count 2 more, 3, 4. Those are the numbers you're going to plug in here. Feel free to use a calculator. All right, so you're going to finish this up, get your y values, and then plot the points. Depending on your y values, your x-axis, which is the horizontal, you might have to move it up or move it down. I can tell that this has a negative. Your parabola should have this shape. So you might want to just move your x-axis up kind of higher like that. I don't know. You'll have to plug in your values and see what you get. All right, so then the next one, do what I was just showing you. Do your A, B, C. We're going to do negative B over 2A. B is -6, and then A is 2. So it's going to be -6, which is +6 over 4. That one actually comes out to be a fraction. So 6 over 4 equals 3 over 2. That's a really weird number to be having to plug in. So definitely use a calculator. 3 over 2 is also equal to 1.5. So in the calculator, 1.5 might be easier. That's what I would do. But that would give you your vertex point, and we do need to know the vertex point. I would count 2 less and 2 more, but I actually want to be plugging in whole numbers. I don't want to be plugging in decimals or fractions. So I would pick a little bit less would be 1 and then 0, and then a little bit more would be 2 and then 3. If you get confused on these for the graphing, just use Desmos to help you. Use a calculator to help you. I do want to see that you have the tables done. So I want to see that you've got your y values. But if you get confused on the actual graphing, feel free to use Desmos. All right, so just finish this up. You'll take pictures of these 2 pages to turn in to Google Classroom. And you don't have to do questions or a summary unless if you want to make these complete focus notes. I'm not requiring that. I just want you to have these 2 problems finished.